Okay, we've got Vagrant installed, and we've got one more dependency we need. And I want to throw this your way and see if you can come up with the answer. It's represented by that dashed line around our VM, and it harks back to that example I talked about earlier with Docker for Windows and Docker for Mac. What component are we missing still? So Vagrant is a tool that helps you automate the creation of VMs, but it is not a hypervisor itself. And depending on your platform or your baby, if it's a Windows machine, you might want to use Hyper-V, or you could use VirtualBox, which is a cross-platform hypervisor. It's a hypervisor I'll be using in this course, which you can also use on Mac. So we need some sort of hypervisor installed, and it just so happens that I have that installed already, but I want to show you where you can find out a bit more about this. So out in the docs for Vagrant, vagrantup.com/docs, if you come under the section called providers, these are referred to as providers. They're more or less your hypervisors. You'll see there are some prominent references here to VirtualBox, VMware, Docker, and Hyper-V. Focus on Hyper-V, VMware, or VirtualBox. If you have a preference, feel free to go that route. Otherwise, you can use VirtualBox like me, and it'll work on just about any platform that you are operating from. Now, in my case, to install VirtualBox, one of two routes to go. Just like with Vagrant, I can come out to the download page for VirtualBox and grab a copy of the latest version of it. So I can say OSX host, click that link there, and I'll start downloading the installer for that. Or I could download the Windows installer. I, however, like that command line tool to manage my packages, so if I list out the installed casks, you can see here for Homebrew, this is all Homebrew terminology, it doesn't really matter at the end of the day, but you can see I already have VirtualBox installed, so I'm good to go. Of course, over on Windows, you might use Chocolatey to install VirtualBox, or you might use a different package manager on a Linux environment. At the end of the day, come over to the command line, type out vbox manage, and then pass the version flag to see what version of vbox manage you have on your machine. You can see here 6.1.16. That's the latest version at the time of recording, as you can see on that past page for the VirtualBox download. So it looks like I've got the tools in place that I need to be able to spin up VMs. I've got my hypervisor. Again, that's the little dashed lines represented here around my VM. I've got Vagrant, which is going to allow me to create these VMs easily with VirtualBox under the hood. It's also going to allow me to pull down pre-built distributions of Linux off of Vagrant Cloud, like I mentioned a moment ago. You'll see how that really rocks. If you are familiar with Docker, you can think of this as the equivalent of Docker Hub, but for VM images. I, to this day, believe that both Docker and Vagrant are so incredibly popular. Yes, Vagrant isn't quite as popular as Docker, but it is really popular. But both of them are popular because they have a simple means of pulling pre-built images for a VM called boxes with Vagrant, or in the case of Docker for containers, images off of Docker Hub. Organization site, and if I come under download, if you scroll down here, there's a link here to download from Vagrant. If you look at that link, you're going to see CentOS/boxes/8. We can even click on that to come through to Vagrant Cloud, another way to get to the official images, if you will, or at least sanctioned images, because they are linked to by the official project, and that's a secure website, so it's probably not very likely that somebody has attacked that website and injected some malfeasant images, so we can probably trust these images out on Vagrant Cloud. So my presumption then is that all of these boxes down here are going to be your official CentOS boxes. And I wanted version 8. I can click on that then. And inside of here, I have a sample of how to get up and running. I even click new here, and you can see the Vagrant init syntax we can use. So I could copy that, and just paste that at the command line here. Not too hard to type out either. What that's going to do is pull down the box that we were just talking about. It'll pull it down in a moment here when we start up the VM with Vagrant up. So it'll grab the box for CentOS/8. This will take a moment to download because it's going to be a bit hefty in size. They're not huge, but they're not small either. And if you have a slow internet connection, it could take a while. Once the box is pulled down, then a VM will be created, and the disks in that VM will be based on the disks that come out of this CentOS 8 box that's out on Vagrant Cloud. So it's a starting point, if you will, for a VM then. A template. And the nice thing is Vagrant works across different hypervisors, so VMware, Hyper-V, VirtualBox, so you have a consistent format for working with these things. Now, while that's downloading, I'll show you one more thing. So that command that I ran, it generated a file called a Vagrant file. And if you look at that Vagrant file, I'll just dump out the contents here with syntax highlighting with the back command that I've installed on my machine. It's a Ruby syntax for configuration. And more or less, you'll see a lot of comments in here. I left the more verbose version of it. You can pass the minimal flag to Vagrant in it to cut out some of these comments. But at the end of the day, really the one line that's uncommented is specifying the box that we provided at the command line. And so then when we type Vagrant up means create the VM and start it up. And so in that case, we need to pull down the box if we don't have it already. Anyways, if you scroll through here, you can learn a lot about how you can create different aspects of this VM automatically. It's really pretty powerful stuff. We'll get into it as we need to. I might recommend that you come down here to the provider section for VirtualBox and configure additional memory and CPU capacity if the VM that you're creating is seemingly slow on your machine and you have the capacity to do so. So for example, I have 64 gigabytes. If the default amount is 1 gigabyte of memory, well, obviously I could probably allocate a few more than that and probably get to a point where I'm working on my learning environments at a much faster pace than if I'm memory resource strapped inside of those VMs just because I didn't configure this. You can uncomment these lines here and start to configure the memory, and there's also vb.cpu, so you can increase the number of CPUs if that's causing you any grief in terms of your learning environment. By the way, this is the documentation for the configuration of the VirtualBox provider, so provider's VirtualBox configuration, out on vagrantup.com. And the settings that I've discussed, memory and CPU, are just a few of the things you can configure. You can even get into lower level aspects of configuring VirtualBox that you might be familiar with if you're familiar with VirtualBox. Basically, as you scroll up here, you'll see various different options available. And then you'll also see other tabs available for configuring this VirtualBox provider. And then within each hypervisor, VMware or Hyper-V, more or less, if there is a setting in the GUI for VirtualBox or Hyper-V or whatever it is you're using, all of these tabs here, they're locked out right now because my VM is running, but all of these settings, in some way, shape, or form, I can configure them via the Vagrant file, check them into version control, and keep a nice history of them. Okay, see that box is done up at the top, by the way. It's now importing that base box as a starting point. Booting it up, you can see ports are being assigned, SSH is being configured. While that's wrapping up, I want to hop over to the VirtualBox GUI again. Astute observers might have noticed this a moment ago. You'll see that CentOS box that we just created. So really, at the end of the day, Vagrant is just automating the process of creating a VM inside of VirtualBox. That's what I want to drive home. If you're using Hyper-V instead, pull open the Hyper-V VM Manager. Take a look. Okay, so back over at the command line. So we've now got a fresh Linux virtual machine installed on my Mac. It could be on your Windows machine instead, or your Linux machine instead, or any environment you're working with where Vagrant will run. And of course, if you're really dedicated, you could just go straight to a hypervisor like VirtualBox yourself and skip Vagrant. I just find it very powerful to use to speed the process up. So we've got a Linux VM up and running with CentOS 8. Now we can look at what it's like to install Docker inside of this Linux VM. So getting to this point was about setting up a learning environment. Now we can go ahead and start with the installation process. Figuring out what to do with a given Linux environment, since there are so many possible distributions and versions and packages and what's supported and what's not, is to go out to the official docs for Docker, come down to the download and install section, and you'll be presented with three choices. We have our desktop editions for Mac and Windows we're not going to be working with, and we have our Linux choice over on the right-hand side here, so we can click that. Basically, this is an index of the various different guides or instruction sets or documentation that you can use. I will scroll down here, and the very first thing you should take note of is the distributions that are supported on the server side by Docker. So we have CentOS, Debian, Fedora, Raspbian, we have Ubuntu, and we have different CPU architectures. So this page here gives us a nice overview to understand if what it is we're trying to set Docker up on is even possible in terms of, is it officially supported? It might even be possible beyond that, but is it going to be something I can find in the documentation here on the docker.com website? And in this case with CentOS, it is. So I could click through to this link, or if I don't find my Linux distribution, I might scroll down here and take a look at some of the notes about other Linux distributions. Notably, what I just said here a moment ago was that sometimes you have derivatives of a distribution. For example, in the case of Ubuntu, we have Kubuntu. If you're using Kubuntu, you might go ahead and follow the instructions for Ubuntu, and then you might have to make some tweaks to it to work for that particular derivative. So sometimes it's about triangulating the closest distribution that is directly supported and has direct instructions for it. So if we wanted to install on CentOS, we would come up to the CentOS platform and click on the link here. And we have a nice guide here. The estimated reading time is 10 minutes. We will work through the instructions here together, at least the portions of this that I think are highly relevant. And then I would always encourage you, and the reason I'm showing this page to you is because you need to come back here from time to time and check to see if the instructions change. Especially if, for example, anything changes with CentOS itself that forces a change within the Docker installation instructions. There's lots of forces at work that could lead to this document changing. For example, the days ago recent controversy around the future of the CentOS project. Not necessarily going away, and who knows what exactly it's going to look like in a year's time or 2 years' time, but who knows that about any distribution. In addition to changes, you should also pay attention to anything that might be out of date. Given all the forces at play and the fact that upstream changes to the operating system or distribution could trigger changes in the Docker install that are not yet reflected here, you should be vigilant to make sure that if something goes wrong with installing Docker using the process here, you use your understanding of the distribution to modify the instructions here as needed. Now I chose CentOS first because I felt like the instruction set was a bit more reduced to begin with, because I want to walk through a manual installation here so you can get a feel for what it's like to just go ahead and install the Docker tooling on a Linux VM. After CentOS, I'll have an example of Ubuntu in this course, and also different approaches to installing the Docker tooling. For example, we will look at a scripted install. If you are not a CentOS person, you don't use CentOS, or for some reason you don't want to follow along with CentOS, that's perfectly fine. Pick a different distribution and use the instructions out on Docker Hub and follow along with me. And triangulate the differences between the two, and you'll probably actually learn more than just following along with CentOS. Now, the first step is to remove old versions of Docker, and because this is a new VM, theoretically we shouldn't have any problems with that. You can run this command, it won't hurt anything, but this shouldn't be necessary in a brand new environment. This would be something if, for example, you were using your desktop Linux machine directly, not a VM, and you wanted to make sure you removed any old copies of Docker before you try to install the latest version. It won't do any harm, so I'll copy over and run the command to make sure that these packages are removed. And as you can see here, there are no matches for these packages. So nothing's going to be removed. And that's because we have a brand new VM. And in this case, the box that I pulled from Vagrant Cloud didn't have any of these packages pre-installed. Now, I should warn you, it's possible you could pull a box down from Vagrant Cloud where somebody added some of these packages in. So it might not be a bad idea just to go ahead and put this at the start of your process to configure a Linux VM. That way you don't have any surprises depending on where you get your Linux VM box from or image from or whatever it is your starting point is. Wherever you get that from, you won't have a surprise because somebody added a package and you didn't know it. So anyways, I'll clear that out and we can move on. Now, when it comes to how we install Docker, we have some choices, and the documentation will present this to you. Depending on the distribution you're working with, it'll link you to the appropriate spots. First up is the one we're going to follow, and that's just going through and installing via Docker's repositories. Really, it doesn't matter which distribution you're working with. The typical pattern is that Docker hosts their own downloads or repositories of their own builds of their own Docker tooling, and you can install directly from those. And so the instructions down below here you can see with install using the repository are going to help you do that. This makes it easy to upgrade typically, as mentioned here, because you're working with a repository where updates can be pushed to and then can be made available to you. In other cases, you might want to just go find the actual packages or package that's being installed, download it, and install it manually. It's probably more for a production environment where you don't have the luxury of an internet connection. Something is very sensitive and needs to be kept secure, and so you need to bring to that machine the version of Docker that you want to install, specifically a package. You can't just reach out to a repository on the internet. This is pretty rare, I would say, though, and I say that because the Docker repositories these days are protected by HTTPS, so they are really secure to begin with. It's going to be a rare case where you need to have an air-gapped system, for example, so you're probably not going to go the middle route. Now, where you might go is this last route, which is very convenient. I used this one time when I was working with a customer. There are some convenience scripts for installing Docker. Essentially, you go to get.docker.com, and at the top of the script here, you'll see instructions for how to execute the script, so how to pull it down and then run it. So it's a quick and easy installation process where there's a lot of magic happening down below, and hopefully everything just works out fine, because if something doesn't quite work out fine, you're going to have to dig through this to figure it out. And of course, that's a nice reason for having test VMs. We can just throw those learning environments away and recreate them if something goes wrong, instead of having to dig through all of this if we, for example, ran this on our own desktop Linux machine. Part of the reason for the complexity of this script is simply that if you search through here, you'll see there are different pathways to execute depending on the distribution. So here's CentOS, here's RHEL, Debian, Raspbian, Ubuntu. So there's a lot of logic to handle different cases based on the distribution and dispatch the appropriate command for that distribution. Just keep searching through here, you'll see more and more instances of these conditional blocks based on the distribution. Again, I actually use this with a customer where we wanted a very simple setup to test the scalability of Nomad, which is a clustering tool. And we needed Docker installed on our nodes, and this is just an easy way to get it up and running. We didn't really care too much about how it was installed. We just wanted to have the nodes up and running with Docker on them. By the way, there's also a test.docker.com if you want to pull down the test build. And just watch this over time, because the various builds will change. For example, just recently, Edge builds were deprecated. Please take note of this last part. These scripts are not intended for production environments. As I mentioned, in my case, we were testing scalability. We were not deploying a production scalable environment, just testing it. And so these scripts fit that environment perfectly. But you need to be very careful in a production environment if you're to try to use these, and it's encouraged that you don't use them. And you really need to understand everything the script is doing. So at that point, you might as well just adapt that to your specific environment, or perhaps go with some of the automated package management installation routes in a production environment. So we have different installation methods to go. I'm going to go the route of using the repository. Join me in the next video for that. Alright, so we've chosen to go the route of installing using a repository. And don't fret if something goes wrong, you can always just delete that VM. I'll show you how to do that here shortly. And just get started again with a different approach if this one didn't work for you. So I'm going this route though. I'm going to grab this very first command here to make sure that the yum utils are present. That will provide to me the yum config manager, which can be used to add Docker's repository. And that way we can find packages that are published via Docker's repository at this link here. If you're curious, you can always just pull open this link in a browser and take a look at what's available. So under Linux and CentOS, you can see the various different versions available, and click into any version, and you can then drill down into and see, for example, the x86 64-bit build. Take the stable build of this. I can look at the packages that are available. And this is what we'll be installing here in a moment inside of our Linux VM. Okay, so back over to my VM. I can simply paste the command to install yum utils. It already was installed, so we're all good. And that means we should have the yum configuration manager available. It looks like we do indeed have that. Grab help for that if I want to. Quite a few options here. So let's just clear that screen out and forget about that for a moment. I can hop back over to the page for configuring the Docker repository, grab that command. And like anything else in life, when you're copying and pasting commands off the internet, one reason to use a VM, especially if it's isolated, is to protect yourself. Make sure that the site you're pulling this from is some site that you trust. Make sure you got HTTPS up here in the browser, and make sure that it's docker.com and not docre.com. And make sure that you know what these commands are doing at the end of the day. So I'll copy this, come over to our Linux VM, I'll paste it in, and we've now added our Docker repository of packages. If you want, you can take a look at instructions for adding in nightly or test builds. But I'm going to scroll down here past that and just jump down to the installation process. So join me in the next video, and we will go ahead and get our first piece of Docker installed, the Docker engine. Looks like we're just installing a Docker CE, Docker CE-CLI, and the containerd.io packages. And then we have some instructions for what might happen in terms of verifying the GPG key, the fingerprint of that, to make sure that it matches. So we're not pulling the packages potentially from a malicious man in the middle of us, and what we think is the Docker repository. I'll come over here, I'll paste that in, and I'm using elevated permissions to do this as well. Docker creates containers that can have virtually endless permissions on a machine, and so it's natural that they're going to require elevated permissions for installation, or at least a tooling for it to be able to create those containers that have elevated permissions will require elevated permissions to install. So I'll run this here. I'll go ahead and accept the installation of those packages. If you're writing a script, you could just tack on a -y to confirm if you know these are the right packages. You'll see that various dependencies of these packages are pulled down as well. Alright, I am prompted to accept a fingerprint here for the official CentOS signing key. I'll pull up in a site to do that. Don't conflate this with the Docker key. The keys match, so I'll proceed. Now in this case, when we see the Docker release CE-RPM, I should be able to copy this fingerprint here and search for it on the web page here. In the docs, you can see that matches, so we are good to go. And I will round out the process of installing the Docker packages. And we've got our complete installation. It looks like it was successful. How might I test that out? Well, I should have the Docker CLI available now, and I do indeed have it available. And before, you saw when I first created this VM that I did not have it available. So it looks like we're headed down the right path. If I want to check a little bit further, I might run the Docker version command. And when I do this, I can get information about the client. So the Docker CLI itself, that's the client. I'll get build information 20.10.1, and then some other build aspects. But I cannot connect to the Docker daemon at the typical Unix socket that it listens on. And so it's asking me, hey, is the Docker daemon running? Join me in the next video for that. Okay, so just a moment ago, we tried to get Docker version information. We got it back about the client. We didn't get anything about the server, and that could be for a number of reasons, number one of which might be that the server is just not running. So if I were to clear out the screen here, if you take a look at var/run, there's no docker.sock. I'm inclined to believe it's possible the server in this case is not started up. So what can I do to check that? Well, it really depends on the operating system. In this case, I can use systemctl and check on the status of the Docker service. And there you go, loaded, but it is inactive. There's also a Docker socket. It's also loaded but inactive. So in this case with CentOS, it looks like the service is not yet started up. And indeed, if I come back to the documentation and start looking through here, by the way, you can install an older version if you'd like, or a different version if it's available, and here's the steps to do that. We'll skip over that for now, though, and go to step 3, which is starting up the Docker daemon. So yes, indeed, we do need to tell the service to start. So we can start up Docker, and now let's do our status check, and you can see both are active at this point in time. The second part is hinting at the fact that that socket is now available. So let's take a look at that and see if that's the case. First off, I want to run Docker version and see what happens. Okay, so it's still not working, but what's the good news here? Before we got a message that asked us if the service was running. Now we're getting a permission denial when we're trying to connect to the Docker daemon socket. And if I look and see if that socket exists, it does indeed exist. If I dump out permissions for accessing that socket, you can see it's owned by root and the group Docker. Now, the Vagrant user on this box, it only belongs to the Vagrant group. So it has no route to go to get permission to access that Docker socket. What's something I could do, though, to get access to Docker? Well, there's two routes we could go. The first route we could go is just we could elevate permissions and run the Docker version command. And this time you can see we get both client and server information. Backing up a moment into the permission denial, instead of elevating, we can grant access to the socket. And one way to do that is via the socket's group ownership. So we need to use elevated permissions, and we're going to modify our user, and we're going to add the group Docker, and the user is Vagrant. Now, before I run that command, I'm just going to terminate that command with Control-C, or terminate that line input, and I want to quick run the groups command again, and show you that groups is referring to the Vagrant user. Now I'll go up and copy that command that I typed out. I'll paste in that user mod command call again. We'll run that. And what do you think happens here if I type groups again? Let's find out. It looks like nothing's changed. What do you think is going to happen here when I run Docker version? We still cannot connect to that socket. So after adding permissions to a group, make sure to at least log off and log back on to a system. In the case of VMs, sometimes you need to reboot the VMs as well. Okay, so I exited out of my SSH session, and then I Vagrant SSH'd back in. By the way, Vagrant more or less just puts a cover over the SSH command so that you don't have to know the inner workings of how it's connecting to the VM. It's just making magic happen. So when I exit out of my session up above here, I wind up back on my host machine, my laptop, and then at that point I can SSH back in, and I've started a new SSH session. So that's a log out, log in. And I'll clear the screen here. Now what do you think will happen if I run the Docker version command? Well, we still have a problem. If you look at groups, you can see we still don't have the Docker group showing up. So if all else fails, as the docs mentioned, sometimes with a virtual machine you might need to restart to ensure that processes are restarted and pick up new group membership. The nice thing with Vagrant is we have a consistent interface to do that. We can use the Vagrant reload command that will stop and then start the VM. Okay, the machine is rebooted. I'll SSH back into it. Now, what do you think will happen here when I run the Docker version command? Oh no, we forgot something here. We need to start the service. And there you go. Now, as the Vagrant user, who am I? the Vagrant user, I can access the server, in this case just pulling down version information. So I could also do Docker info. Great. Both client and server information are coming back. I could even do Docker PS. There you go. We've got our running containers. There are none. We can list out images, and we have none. So it looks like we have permissions now just by adding ourselves to that Docker group. So keep that in mind as a step in the installation process. Who needs to have permission to the socket, the Unix socket in this case, which is what's used by default? Just so happens that I rebooted my machine since the last video I recorded, and I thought I would take this as an opportunity to show you what it's like with Vagrant to check the status of your VM. So you can run the Vagrant status command to actually do that, and in this case you can see it is indeed powered off. Of course, you can confirm the exact same thing by taking a look at your hypervisor, in this case VirtualBox, and you can see here we're powered off as well. I would encourage you to continue to use Vagrant to control the status of your VM. What should we type in to turn this VM back on? Well, if you just look here in the output, you'll see we have an example that says, hey, simply run Vagrant up. So we'll do that. By the way, something I found really helpful with Vagrant, you might have noticed at times I type out short little snippets like VU, and then it expands into the full Vagrant command. These are just aliases I've set up, and a little custom code I threw in was Z shell to expand out the alias, mostly so that you can see what's actually going on and you don't see VU instead. I would encourage you to at least use aliases and maybe look at some code samples online for expanding aliases. When it comes to not just Vagrant, but really anything, I use this with Docker and every single command line tool I have. So let's boot this thing up, and this will bring the VM back online. You can even check over in our GUI, and you can see we're already back up and running, and over on the right you can see a preview of the window.
And what I did just to show you the code, I created a user, Aquaman, who just has data reader and data writer. Now as Aquaman, if I try to view the first name, last name, and code name, I cannot view last name because it's encrypted. But just to see the data masking, notice last name, I can't see the value. It's masked to me. Now, to kind of prove a point, if I prompt unmask Aquaman and then run the query again, now Aquaman can see that last name value. But generally, we really don't trust Aquaman with that type of data, so we'll revoke that once again. Now, when Aquaman tries to view the data, if he doesn't know who Batman or Superman really is, which is probably for the best, no one really trusts Aquaman. Therefore, in terms of encryption, we have a number of different options for accessing the database to the data correctly. In this lesson, I wanted to quickly touch on a few considerations if you do choose to bring your own key, a customer managed key. As previously explained, orchestrate all of the data services, Azure Storage, Azure Cosmos DB, Azure Managed Database for Postgres and MySQL, and Azure SQL Database and Managed Instance, I can use a customer managed key, a CMK. I'm going to place that in Azure Key Vault. The important part is, if it's not system managed, I am now fully responsible for the life cycle of that key. I.e., I probably should be rotating that key periodically. If I believe that it's some way, then I should rotate the key. And it is unaffected for the data platform, but eventually there will need to be an update performed to the key and then the data service. Now, I can practically do that. For things like Azure Storage, there is a sync option between Azure Storage Account and Azure Key Vault. For SQL Server, it will actually go some workloads need data to be encrypted even when it's being utilized on the server itself. Now, is SQL always encrypted, as we saw before, encrypted column? But what will happen is, always encrypted with secure enclaves will provide additional functionality to the always encryption technology. Essentially, this will leverage these new Azure confidential computing capabilities using new hardware features like the Intel SGX that actually have this enclave inside the environment that is always protected and always encrypted, even when it's being utilized. The new virtual machine series, the DC series, actually exposes these capabilities, and going forward, we'll see this start to be leveraged by Azure SQL Database. In this lesson, I want to talk about data discovery and classification. Often we need automatic classification to help supplement any user classification of data. Often we don't even know what data we have. We don't know how it should be classified. It is confidential. Azure SQL Database has discovery and classification as part of its advanced data security add-on feature. I want to go and actually show this. Now additionally, the Cosmos DB, I can leverage JSON metadata to classify attributes in items. So I just want to touch on there are capabilities I can perform in Cosmos DB as well. Here looking at my database, I can scroll down. Under security, I can see I have data discovery and classification. Here it's showing me the number of classified columns.
Now that we have a lab environment set up, I want to move on to talking about Docker context. And to understand what exactly the purpose of a context is, we need to take a step back, look at the layers of the onion, if you will, and specifically take a look at the lower level of what exactly is a container. That's what we're creating at the end of the day. If we peel back a container, we'll find inside of it various components that are comprised of lower level functionality in the operating system itself. In our case, inside of Linux. For example, networking. How does a container communicate with the outside world? Or maybe it doesn't. We also have processes. How can we isolate the container process? File systems give us the ability to provide a unique set of files as if the container had its own hard drive plugged into it, is the way I like to think of it. And the initial contents of that hard drive I like to think of as what you're pulling down from the image that you get from Docker Hub. Deeper yet is IPC and users and groups, both via advanced namespace functionality inside of the Linux kernel. Now, this is as low level as I want to get. I just want to point out that there's a lot of pieces that are put together. How do we get the image to provide the file system? How do we set the file system up? How do we create the process and isolate it? All of that requires a lot of code to execute, and we could stitch together ourselves by hand. These are just low-level system calls in a lot of cases, or in other cases, we're just talking about using an existing tool like perhaps IP tables to work with networking. But thankfully, we don't have to do that because we have a tool like Docker Engine. It can hide away all these lower level components and help us work with some basic commands to create a container, to pull an image, to build an image, to stop a container, to restart it, to execute another process, to get inside of it and look around, troubleshoot. So we can work with commands that get translated down into low level system calls thanks to Docker. And so the layers involved in doing that, to get to that final point of creating a container, for example, we first start with the Docker CLI that we just installed. It forwards various requests through a socket, by default a Unix socket on the single machine setup that we had. That socket is used to communicate with the Docker Engine API. Those API calls are handled by the Docker daemon that is hosting that API. That's how you communicate with it. So really we have two primary tools. We have the Docker command and the Docker daemon, and they communicate through these various layers. And at the end of the day, you're creating containers with them, or other resources that are going to be used by containers. You might be managing images, for example, pulling them down from Docker Hub. Or you might be creating a container, and so you need a file system set up for it. And then there are networking considerations, adapters, virtual networks. even exposing ports depending on the application you're running. For example, if you're running a web server, you might want to open up the web port so that people can access the web server's content. And of course, isolated processes have to be managed via PID namespaces, essentially a hierarchy of processes that are isolated. They're still just processes running on the machine, but that has to be handled by the Docker daemon. Cgroups are used as well, putting limits on and monitoring the resource utilization of a container. And then various different security components are stitched together to hopefully make the container a secure environment to execute software inside of. Now, along the way through these various layers, you'll find there are some choices that can be made. For example, a Unix socket is created by default, but you could swap that out for a TCP socket because the API itself is a RESTful HTTP API that can be either run with just plain text HTTP, or you can add a layer of security with TLS and HTTPS. If you really want a firm understanding of what the Docker engine does for you and the subcomponents thereof, I would encourage you to take a look at some of these lower level aspects. And a great place to start is looking at this man page for namespaces, notably a listing of the types of namespaces you can work with. There's also a list of system calls related to namespaces. In addition to being a great resource, I mention this man page because namespaces are a fundamental part of the components that Docker uses to build up a container. So my challenge to you is to work your way through this man page and anything else that you need to understand namespaces. And then I want you to start up a Docker container. And in my case, I will use the bash image. You can use any image you would like. This is a lightweight image that just starts up a bash shell. Just going to take a look at the processes in here. I can change to my home directory, print out the path, and even list out the files. So now my challenge is open up a second terminal window and SSH into your Linux VM or wherever you have your Linux VM at. Open up two terminals to it. I want you to circumvent Docker and get into or break into the namespaces that are isolating this container that you created up above. So now I'll give you one hint. You'll need to learn how to use a command called nsenter. And for that, you can look up the man page. It has a lot of great information inside of it. All right, so now if I type out ps, what do you think will show here below? Hop up on top and we'll do the same thing. What do you think will show here? So we are indeed inside of the same set of namespaces. And to really prove that, let me change to my home directory here. Print that out again. You can see we are in the same root directory in both places. I can even do something like list out all the files. And then I could touch a file here. And what do you think I'll see up above when I list out the files? Do the same thing here. How about down below? As you can see, we are working with the same mount namespace in this particular case. So if you can compose these low-level components together without Docker, you should have a better understanding then of what Docker is doing for you at a higher level. For example, on the level of the Docker engine, or maybe even the Docker engine API, or even way up the stack to the Docker command itself. In fact, if you take a look at the Docker container run and then grab the help with the help flag, if you look at this command, you will see reflections of what we just saw a moment ago with namespaces. For example, here's user namespace. If I scroll up here, here's a setting for PID namespace. There's the word mount. We have networking. We have networking flags all over the place, actually. We have a host name and another familiar flag, the IPC mode to use. These are just a few of the reflections of those lowest levels bubbling up to the top level command. So when we make requests to Docker, it can pass along the arguments we need to the lowest of levels. And if you look at what we installed in the last module, if you were to pull back the covers, you would see these layers that we just talked about, all on a single machine. I like to think of this setup as somewhat a personal setup, where on my personal development machine or workstation, whatever it is that I use day to day. And we saw in the last module that without any extra configuration, we'd have to elevate our privileges to run commands against the Unix socket. And so we needed to add ourselves to the Docker group to be able to access the socket. In our case, we needed to add the vagrant user to the Docker group to be able to fire off commands that would eventually get to the Docker daemon. For example, maybe we send off a request to create a container, or stop a container, or pull an image, or push an image, or whatever it might be. So you can start to see there is a client-server type setup. For example, it doesn't have to be the Docker client. It could be Docker Compose as a client instead that is sending a request off through the socket to create another container. Now in the last module, we set up on CentOS a single machine, a VM in our case. We put all these tools on it. And of course, we could swap out for a different distribution, perhaps Ubuntu. I like to think of this as an all-in-one setup. In real life, though, we sometimes run out of space in our all-in-one setup, or we just have a need to run